Sit down for this one. Grab something to take notes with, because what I'm about to walk you through genuinely changed how I think about red light therapy. Here's the sentence that broke my brain the first time I heard it, and I want you to really let it land. Your cells make their own light. I don't mean that as a metaphor. I don't mean energy in some vague, feel-good, wellness poster kind of way. I mean literal light. Your mitochondria emit actual photons, faint, real particles of light, coming from inside your cells right now as you sit there reading this. Scientists have a name for them. They're called biophotons, and your mitochondria appear to be the main source of these tiny flickers of light. Now here's where the whole story flips upside down, and this is the part I need you to hear me out on completely. There's growing evidence that red light therapy isn't just dumping raw energy into your cells the way we always assumed it did. Instead, it might be working by talking to a light-based system your body is already quietly running in the background without any of us noticing. And if that doesn't sound wild enough for you yet, then just wait. Because in a minute, I'm about to sound like I've completely lost my mind. So let me be straight with you before we go any further, because you deserve honesty more than you deserve hype from me. A lot of what I'm about to share is cutting edge, emerging science. Some of it is still sitting in preprint. Some of it lives only in a petri dish. Some of it is being actively argued over right now by researchers who genuinely don't agree yet on what any of it actually means. This isn't a protocol video. I'm not handing you a step-by-step routine to follow tonight. This is a map of where the science is heading, and it's some of the most fascinating frontier research I've come across in years. So here's the exact path we're going to take together. First, the biophoton idea. The strange notion that your cells communicate using light, and what researchers found when they shined red light on stressed cells. Then we'll come back down to earth and ground everything in the solid, boring, well-established science of how red light interacts with your mitochondria. That way, you'll see exactly why the new, crazy-sounding stuff is even plausible in the first place, instead of just taking my word for it. And finally, the frontier. A 2025 discovery about red light rebuilding a tissue your body famously stubbornly struggles to repair on its own. Let's take the journey. Start with a piece that honestly feels ripped straight out of a science fiction script. For decades, researchers have known that living cells give off an ultra-weak glow. It's so faint that you'd never see it with your own eyes, not in 100 years of staring at a single cell. But point a sensitive enough instrument at that cell, and you can literally count the individual photons streaming off of it, one by one. Those are the biophotons. And the leading thinking is that your mitochondria, the little energy factories humming inside every cell, are the primary source of them. Now, some researchers push this idea a step further, and this is where it gets genuinely strange. They think cells might actually use this light as a signal, a way of broadcasting their own health status to the world around them. Almost like a language written entirely in light, running underneath everything else. Picture that for just a second. Your mitochondria having an entire silent conversation with each other, one that we can barely even eavesdrop on with our instruments. Here's where red light therapy crashes right into this story. In a 2025 study, researchers watched what happens to these biophoton emissions when you treat cells with light, specifically red and near-infrared light. And what they found was something genuinely deeply strange that I still think about all the time. When the cells were healthy and at rest, The red light barely touched their light emissions at all. Almost nothing changed. It was quiet. But when the cells were stressed, hit with a toxin, drowning in oxidative stress, struggling to keep up, that's when the red light changed the biophoton output. Sit with how big that actually is for a moment. It suggests red light isn't a blunt instrument that just revs up every single cell equally. It's context dependent. It does very little to a perfectly healthy cell, and it steps in specifically, deliberately, when a cell is actually in trouble. Think about how differently we usually talk about this stuff. We treat red light like a simple light switch. More light, more energy, everywhere, all at once. But this research hints at something far smarter than that. The effect only really shows up where there's genuine dysfunction, where the mitochondria are already struggling to cope. And you can actually see that struggle happening in the biophoton release itself. It's less like flooring a gas pedal and more like a system that responds. Here's the reframe that got me, the one I can't stop thinking about. If cells really are using light to signal their state, then shining the right wavelength changes everything. You're not forcing anything on them. You're joining a conversation they're already having. You're not shouting at the cell. You're answering it back. And I'll be honest, this is all still being figured out. It's being debated, poked at, argued over in labs, but the fact that we're even here is remarkable. So before you write me off completely as someone who's lost the plot, let me pull us back onto solid, boring, dependable ground for a minute. Because the only reason serious scientists are taking the biophoton idea seriously at all is that the established mechanics of red light are absolutely rock solid now. And here's the thing worth remembering. They weren't always rock solid. 15 years ago, plenty of smart people thought red light therapy was complete and total nonsense. Today, the core mechanism is extremely well documented. This part isn't speculative anymore. This is textbook, accepted, boring science. So let me actually explain it to you simply. When red and near infrared light hit your cells, the main thing absorbing them is an enzyme called cytochrome C oxidase, buried deep inside your mitochondria. It's a critical piece of the electron transport chain. Think of that chain as an assembly line that collects electrons to ultimately produce AP, your cellular energy currency. Here's the elegant part that I really love. Under stress, a molecule called nitric oxide can gum up that enzyme, jamming the whole assembly line badly. When that happens, it chokes off your energy production. But red light comes in and knocks the nitric oxide loose, freeing the enzyme right back up. Electron flow resumes. Energy production climbs back up to where it's supposed to be. It's clean, it's simple, and it's been proven over and over again. On top of that, the light also triggers a brief, small burst of reactive oxygen species, a tiny hit of oxidative stress, which sounds bad, but isn't. Counterintuitively, that little bit of stress actually acts as a signal. It flips on the cell's own antioxidant and repair pathways, waking them up to get to work. Hold on to that idea tightly, because it becomes really important the moment we get to the cartilage discovery in just a few minutes. Trust me on that. So, the accepted story is already deeply mitochondrial. Light goes in. The energy machinery starts running cleaner. And the cell's own repair systems quietly switch on. Now notice how neatly all of that clicks into the newer biophoton research. In 2025, the Nobel Prize in Physics went to work on quantum tunneling. And we're now seeing that same quantum behavior happening inside your mitochondria, where protons actually appear to tunnel across membranes in ways that shouldn't be possible. These aren't just tiny energy factories anymore. They're quantum machines. Real quantum engines running inside every single cell of your entire body, right now. Here's the thread that finally ties both worlds together for me. If a healthy cell already has a smoothly running electron transport chain, there's almost nothing to fix. So not much changes when you shine light on it. But when a cell is stressed, enzymes jammed, mitochondria sputtering, suddenly there's real room to respond. The light finally has something meaningful to do. That's the word I keep coming back to over and over again in my head. Adaptogenic. It adapts to need. The established science and the cutting-edge biophoton work are both pointing at the exact same conclusion. Red light does its real work when mitochondria are damaged or strained, which is precisely why people with metabolic dysfunction seem to benefit the most from it. There's simply more for the light to actually fix in the first place. Your mitochondria aren't just energy factories. They're an antenna, a beacon, a quantum engine, all at once. And once you see them that way, the frontier stops sounding crazy. So, if red light really works at the level of a struggling mitochondrion, I have to ask you the obvious next question that's been nagging at me. What can it actually push a cell to do? Can it push a cell to rebuild in a way the body normally can't manage on its own? A study released at the very end of 2025 brought that exact question to life, and it's the reason I wanted to make this for you today. Researchers took chondrocytes. Those are the cells responsible for maintaining the cartilage in your joints. And cartilage is famously one of the hardest tissues in your body to repair. There's almost no blood supply reaching it. The cells inside it barely divide at all. Compare that to your gut, which churns out fresh cells constantly at blistering speed. Cartilage does the complete opposite. Once it wears down, without stem cells or serious intervention, it comes back agonizingly slowly, if it ever comes back at all. That's exactly why worn-out joints are such enormous business. The surgeries, the injections, the endless desperate attempts to somehow coax stubborn cartilage back to life again. So in this study, researchers shined a specific wavelength of near-infrared light, around 940 nanometers, directly onto living human cartilage cells to see what would happen. And with the right settings, those cells ramped up production of the exact building blocks of healthy cartilage. Type 2 collagen, aggrecan, glycosaminoglycans, the raw materials of the matrix. In plain terms, the light nudged these barely dividing, notoriously stubborn, half-asleep cells into actually rebuilding. It woke them up and put them back to work. And there's a second detail here that I genuinely love. When you grow cartilage cells outside the body, they tend to drift, losing their identity and degrading into something generic. It's one of the most frustrating, persistent problems in the entire field. But the light actually helped the cells hold on to their cartilage-building identity instead of falling apart completely. It didn't just switch on production. It kept the cells being exactly what they were supposed to be in the first place. That's a remarkable thing to see happen. Now I have to be honest with you, the same way I've tried to be honest this entire time. This is in vitro. Isolated cells sitting in a dish. It's not a living, weight-bearing human knee out in the real world. I am absolutely not telling you that red light is going to magically regrow your joints, but the direction is what completely floors me. We're standing at almost the exact same spot we stood 15 years ago with the mitochondria research. Back then, nobody believed that light could do anything meaningful to a cell at all. And now that idea is textbook. It's boring. It's completely accepted. And using non-invasive light is genuinely low-risk, low-hanging fruit. It's part of why red light has quietly spread across professional sports, treated as an obvious edge rather than a gamble. Taking one of the least repairable tissues in the entire human body and making it potentially repairable, that is not a small thing at all. That's a door opening. So step back with me for a second and look at the whole picture we've just built together, piece by piece, from the ground all the way up. We started with the old simple story. Red light creates more energy in your cells. That's it. Clean and easy. But now we're seeing something much bigger. Cells emit their own light, and they may actually use it to signal their own health to the rest of the body around them. That changes everything. An unhealthy mitochondrion in one corner of your body might, in effect, be broadcasting a quiet message. Hey, we're really struggling over here. Something's wrong. Send help. And red light isn't overriding that signal or drowning it out. It's participating in it. It's joining the conversation your cells have been having all along without you. At the frontier, that same light appears able to nudge your body toward repairs it simply can't pull off alone. Repairs we assumed were basically impossible until very recently, and we're starting to see the very same hints with plain sunlight too, that those photons might be doing something far deeper than just warming your skin and giving you a tan. This goes so much further than proteins, fats, carbs, and calories. It reaches all the way down into the quantum machinery that's quietly keeping you alive every second. Protons tunneling through mitochondria, cells whispering to one another in a language made entirely of light. It's almost too strange to believe, and yet here we are. We're early, genuinely, truly early. Most of this is still being argued over in labs and buried in preprints that haven't even been fully reviewed yet. But every so often, if you're paying close attention, you catch a science in the exact moment it starts to turn. And this feels like one of those moments. Your cells make light. Something out there is listening to that light. And we are only just beginning to understand what they've been quietly saying to each other this entire time. So keep your eyes on this space over the next few years, because I have a strong feeling the story is only going to get stranger from here.